I got the most unique and original and interesting question I've ever had the other day. The question was, what was my favorite alpha used in an exponential smoothing model? Honestly, I've never even thought about it before, but I figured out an answer. Let's get to it. Welcome. Another episode of IBF On Demand. I'm your amazing, fun, and not so humble host, Eric Wilson. You can find me at eric@ibf.org. That's eric@ibf.org. Thank you for tuning in once again. Thank you for the following. Thank you for the subscribing. Please continue to find me on LinkedIn, YouTube, wherever you get your podcasts. Found out there's a direct correlation from the more people that follow me, the more followers I have. So please help us out and continue to follow. We do have a sponsor for this as well, Arkiva, your one-plan S&OP software solution. Thank them for being on board still. I'm excited 2022 is off to a fantastic start as far as conferences is going. We're actually back live in person. That's actually where the question came from in the tease, was actually at a conference. We got more great conferences coming up as well. You can check out the site ibf.org. Go to the events page. There's a lot of great events coming up. I want to highlight June is an amazing conference back in Chicago. That's where I just came from last week. We're going to be back there in June doing an S&OP Best in Class conference, which practitioners are sharing what they're doing. It's a couple different tracks. A lot of thought leaders are going to be there. It's a great conference. There's going to be a lot of people there focused on S&OP, the end-to-end process, everything from product demand, supply, executive reviews, S&OE, which is a hot topic now as well. Everything about S&OP and S&OE. It's June 6th and 17th. I'll actually be doing a workshop the day before on the 15th. So if you want to come up a day early, you can check out my workshop as well. Kind of an intensive on S&OP best practices. The whole thing's going to be great. S&OP, Chicago, pizza, hot dogs, fun. You missed the Green River, but there's a lot more to do there. So please come out and check it out. IBF.org, events page, June 16th and 17th, or come a day early for my workshop as well. It's going to be a great conference there, so please make sure you check that out. Today, we're going to talk about not my favorite alpha after all, but my favorite method. Actually, I'm going to talk about a lot of different methods and a lot of different types of methods out there, because I get this question a lot and I wanted to address it. Not just what's my favorite alpha for an exponential smoothing, but what exactly is an exponential smoothing? What other methods and models are out there? You go to these systems sometimes, there's 40, 50, 60 different methods, and it landed them all and took the best pick of this is the one. Why did it pick that? What do these other methods do? I'm going to give today just a high-level overview of all the different methods you may find in that system of 40, 50, 60 different types of methods. What exactly are there? Why are they all there? What's the use of them all? What exactly is out there and why? Because what you find out very quickly is every problem you face is not a nail. You can try to take a hammer to every problem there is, but it's not going to solve every problem out there. There's a lot of different problems, meaning there's a lot of different data sets out there. There's a lot of different uses for your forecast, a lot of different ways you're trying to forecast, a lot of different patterns in that forecast, internal, external data, time series data, cross-sectional data. There's a lot of different ways that you can look at bringing the information in, and there's a lot of different ways to model that information. So with that, you'll find out every problem is not that nail. The hammer doesn't exactly fit. What you need is a toolbox. You need a toolbox full of tools to be able to get the job done properly. So today, I'm going to open up a common toolbox, kind of take a peek inside, and give you some generalities. I said it's going to be a high level today, but some generalities of what you may see inside some of these toolbox and why these different tools are there. And when I'm talking about tools, I'm talking about different methods you commonly use in forecasting. So when you're looking at forecasting, There is a gambit of different methods that are available. Everything from almost a pure qualitative type of method to almost a pure quantitative type of method, and everything in between. Looking at it, you can actually see on the far left what you're looking at as far as a judgmental, empirical type of models. Models where it's subjective, opinion type of based. It's pure knowledge at base is what you're looking at, where someone's providing an input that is almost purely subjective. On the far right, that's when we get into the unsupervised type of machine learning people call AI or things of that sort, which is, a multi-level type of neural network, deep learning, or if you're looking at some types of unsupervised clustering type of algorithms that exist. But these are more the intelligent type of learners, where the machine is actually deciding on, the features. Machines are deciding on groupings. Machines are deciding on optimizing the parameters, the coefficients, things of that sort. So it's really driven by machines as they learn the test data set or data that you are feeding it. Those are the two extremes. Everything in between is everything else in the toolbox. From common type naive models to causal or relationship type models to really more extrapolation, either by extrapolating a pattern that you're finding in some kind of relationship or causal, or extrapolating a pattern in a time series, whether it be level, trend, seasonality, and finding one of those patterns, isolating one of those patterns and extrapolating that forward. That's kind of in the middle. But as you can see with the chart, there's at least 30 different models are the most commonly used from everything from one end to the other. So what exactly is the right ones, and how do we use the different methods then? Well, there's really two extreme views then. On one side is going to be the statistical forecast. That's some kind of Skynet. And I've watched the movie. I'm scared of Skynet. And the results, well, they should be completely ignored because we don't really want machines to take over our forecasting process, because guess what? We need to provide that insights into it. And that's one extreme. The other extreme is really sophisticated systems. They're unbiased. It's mathematical formulas. Computers are truly unknowing, and therefore they should not be questioned, and we should do whatever the system says. That's the other extreme. And obvious, there's two extreme views in there. The answer, most likely, the answer to every question in the universe, 42, but the answer is somewhere in the middle is going to be your answer. And that's truly what you have. And that's the reason why we need that toolbox full of different methods, because there's really no extreme that works all the time, every time. There's a case sometimes for, pure judgment. There's a case for maybe a sophisticated type machine learning. And generally the answer most likely is somewhere in between or a combination thereof. When you're looking at exactly then where you should be on the spectrum, which model is going to be the best, it's really about balance then. I think the best answer I generally give, and it becomes now a joke at the conferences, so you can see me at a conference when I ask a question, here's most likely going to be the answer. It depends. That generally is the answer, because it's not a cop-out. It truly is what you're looking at as far as balancing those two extreme views. We're balancing a lot of other things too. We're balancing time. How long does it take to really, put together the model? How long does it take to train it? Is it a model that's going to take months to really build out and then code, and then it's going to, when you push the button, it even takes 2 weeks before it comes back with an answer, before you have to fine tune it and run it again. There's a time component you have to consider. Or is it something simple, easy, back of the napkin you can do? So there's a time component. There's also the interpretability that you have to be considered, versus how precise or accurate you're looking at the model as well. Balancing those two things, I think, becomes key in any type of decision on which model you're looking at. Because you can find some models that may be more accurate, that giving it enough data, be able to program it, you might be able to fine tune it and produce more accuracy or precision with this model. The problem is you may be at the expense of some interpretability. So what we're going to do is trying to balance those two things. On one quadrant, we're looking at accuracy. As it becomes more accurate, unfortunately, sometimes explaining it or the interpretability becomes more and more difficult. Take an artificial neural network. I mean, yes, you can look at the M5 competition. They dominated. A lot of these, types of models, and looking at random forest, things of that sort, dominated as far as in that competition. At the same time, interpretability, if you're going to be using it inside your organization and talking with some supply chain, where did all those nodes come from? How do we connect? It becomes more and more difficult to even the user sometimes to understand exactly how it came upon that answer and how to interpret and how to explain what exactly it's doing in that. Now, very well, you may be able to, but a lot of planners, it becomes more difficult. So when you're looking at something, the other side of it, yes, naive forecast, very simple to explain. It's what happened last month. It's a period that I've known happened in the past. I've seen it happen last period, so there's a probability it could happen again. So it's very easy to interpret that it's a value that occurred last month is what I'm going to be putting this month. Or last year, comping, I'm going to put the same value this year. It's very easy to explain. On the accuracy, it's not quite as accurate maybe than as going with a exponential smoothing or adding other types of external variables for regression. So you have to really balance that interpretability, being able to explain it inside your organization, explaining it to executives, being able to run the model again and understand why it's a different number this time when you're feeding in different parameters, why that interpretability, balancing that versus what accuracy do you need out of this model? Because you may not need 100%, you're not going to get it, but you may not need 98% precision with this. You may have more tolerance that you have to be able to plan with, and there's a diminishing return as far as that, putting resources and putting effort into it, especially when you add that time component into it as well. So there's a lot of different things we're kind of balancing when we're figuring out what exactly is the right tool to use for the problem we have. So now kind of transitioning, I want to kind of look at some of the most common methods, kind of the categories of methods, and then explain a little bit about each of those methods and exactly what are the most commonly, as far as looking at IBF research, looking at organizations, systems, and what they're as far as results as systems that most people are using. So based on that research, these are the most common methods that are being used in forecasting and demand planning, business forecasting and demand planning today. So I'm going to go through each of the different categories and kind of give an overview of that with the most common. First of all, starting on the far left, we're looking at those judgment methods. And I'm not saying judgment has a place. It has a place in a forecasting. It's not necessarily a bad method, especially when I have zero or no relevant other historic data available. If I have no historic data, i.e. new product, new customer, something of that, something new to the organization. Or if I don't have the history and I don't have external variables to be able to extrapolate or explain it, I have nothing else to go on. Judgment may be the only thing I have and is a forecast. You can also use it to adjust other quantitative type of forecast. When there's informed judgment of variable, when it adds value. In any forecasting process, you're trying to minimize your error and reduce bias, but you do that by bringing in the relevant information. That relevant information can be data, it can be external data, it can be internal data, it can be different features. Those are relevant information. Relevant information can also be judgment. There's things systems couldn't pick up, features wouldn't be able to understand without that human insight into, we're going to be placing this on an end cap this week. It's going to change the profile of how sales are going. We're opening up this new region here. That's information that I need. we're going to be able to run promotion, special promotion. The retailer is going to be running these promotions on this item for this week. That is information that could be judgment they're putting in. It could be, marketing, could be sales, could be a lot of different things that could play into overrides into a statistical model that you already have, but it's a judgmental method you're bringing in. Understand, though, there may be bias. So understanding those biases that come in and helping be able to filter those out is one of the things we need to do as good demand planners. Some of the most common methods utilized is simply just a Salesforce. This is more of a Salesforce, kind of aggregation roll-up, where each of the individual salesperson is going to take a guess of, hey, this is what we're going to sell. This is what I'm going to sell. Here's my targets of what I think I'm going to sell this month. So each person is creating their own forecast based on their own knowledge of what they have at the local level. You simply compile those up, aggregate those up, then you come up with item, customers, region, brand. You come up with higher level forecasts that will drive production, purchasing, things of that sort. But it starts off with a judgment of a sales at the base level, and you aggregate those up. A jury method is more of a group votes to a consensus forecast. Expert opinion, very similar to which is someone has an expertise or knowledge about something in the forecast, an item, a customer, a promotion, something, and they're providing that expert opinion. Could be an individual group that generates a forecast or part of a forecast or override to a forecast. That's an expert opinion. And then finally, you could actually put some structure to a judgmental or subjective type method, like a Delphi method. A Delphi method is more of a systematic way of that jury method, where you pretty much have a blind type of approach. Everybody submits their own opinions or forecasts. You then will take off your high lows, you resubmit, people come back. What it does is it drives to a mean that is relatively not that far off from what a forecast should be. Time series method. Time series method. Statistically, right now, 58% of organizations right there are doing time series as their primary forecasting method. 58, almost 60% are primary forecasting method. Most every system, you're looking at time series, which is understandable. Time series, sequential data, historic data that you can draw from, like order data, shipment data, things you have within your own four walls most of the time. That's time related that you're looking at. Those, you can actually look for patterns, whether it be level, trend, seasonality, or figure out there's a lot of noise in it. But you're really looking for those patterns in it, isolating one of those patterns and extrapolating that pattern going forward. So part of the expectation with time series method is the pattern in the past is a reasonable expectation that it's going to repeat itself in the future. So with that, it works better if you have a stable environment, longer product life cycles, and it works for shorter type of forecasts, because the further you go out, the more unlikely it is that it's not going to repeat the past. But if you have a stable pattern, longer life cycles sometimes, and you have a shorter life span, and when I say shorter, I mean next week to what's going to happen a year and a half from now type thing. 18 periods, 20 periods going forward, maybe 24 periods going forward. That is a shorter type of time horizon for the forecast. It's used a lot. I said 58%, almost 60% of the companies. It's most popular out there. It's inventory management. You can use it. You're looking at demand planning as commonly used. It feeds a lot of the sales and operations type of planning as well as a forecast. Annual budgets can operate off of this as well. The one thing it does, though, is when I looked at level, trend, seasonality, noise, it doesn't do anything to explain that noise. So noise generally is a external or other type of variable to help explain. And things that aren't as stable, things that are new products, things that are trying to forecast further out, you're probably going to have to start looking at external variables. But that said, I said it's a very commonly used method. Some of the most commonly used methods is a naive forecast. Yeah, a naive forecast, that's my level. Of the level, trend, seasonality, I'm isolating on the level and extrapolating that forward. What did I do last month? That's what I'm going to do next month, and the month after that, and the month after that, and the month after that. It's a new level. So it takes the actual value from the previous period, makes it this period. A seasonal random walk, that's a random walk. A seasonal random walk would take last year, the same period, last year March, what the actual was would be this year's March forecast. Averaging models. Averaging models are very common. Everything from a simple moving average, opposed to using one single point for a naive. Now I'm going to take more data points into consideration. But if I take more, it's going to smooth it, and I'm going to hopefully get a better value, more to an average value over multiple points. It's an averaging model. It could be a simple moving average, or you can start adding in trend. Looking at trend by looking at the changes from one period to another and averaging those out. So it could be any kind of incremental change that I'm averaging either unit or percent over time, and extrapolate that trend going forward then with averaging models as well. Decomposition models will actually try to take out the individual components, deseasonalize data, take out the seasonality, find the trend component, add the trend back in, then re-seasonalize the data. So ultimately it's looking at that trend, seasonality. Sometimes it looks at cyclicality if nobody has that much data. But if you did, cyclicality as well. And takes it apart, isolates the different components, puts it back together. Originally used by the U.S. Census Bureau. It's a good statistical method, even if you don't do it exactly the way it was done, explained as from the U.S. Census Bureau. From statistically, there's still components that you use every day, i.e. seasonal indexes, being able to deseasonalize data, being able to isolate trend components, looking at it from almost like a linear trend using time. Those things can be utilized on an everyday type of basis inside your planning system. And then exponential smoothing, these are the most commonly used. Anything from a single exponential, double exponential, whether it be Holt model or a Winters model, or guess what, put the two together. I now have a Holt Winters model, which is a level, trend, seasonal model. So it's looking at all three attributes of time series, being able to create a exponential curve where you're weighting the past exponentially as it goes past it down using my alpha, beta, gammas. There's the question came in with my favorite alpha. All that, not getting into those, I may do another podcast on exponential smoothing. There's a lot of different varieties of exponential smoothing. And it kind of naive as a single point, average I'm taking multiple points. Now I'm taking multiple points and weighting them differently and looking at not only level, trend, but seasonal. And level and trend can be additive or multiplicative, linear or exponential. Seasonality can be additive or multiplicative. So we can put the model together in a lot of different ways. Most of the systems you're in going to have exponential smoothing be one of the most commonly methods that it utilizes for, because it is a versatile type of model if utilized properly, and you as far as tweak it properly then as well. Be careful with best pick, but if you look at modeling it, it can be a very powerful type of model for time series data because it is interpretable. It is pretty much easy to understand. It's easy to really put together. It's easy to repeat. It doesn't take a lot of data to be able to do. So it's actually a good model to be able to understand and start utilizing. And Lewandowski, that's a form of a exponential smoothing. A couple podcasts ago when we talked about the gentleman from the M5, he used a variation of our Holt Winters with just a different distribution. So it's a commonly used type of methodology that can be adapted. Another type, all data is not time related. It's not sequential. Some things are cross-sectional. Some things exist outside of your own four walls. That's when you get into causal or relationship type methods, where a pattern is expected it as an external variable that can explain what's happening with the forecast. Housing starts, weather, oil rigs, something, GDP. That is an external variable that can help explain internal forecast. That is a causal. Relationship type models are proportion, where it's part of a whole. This could be a slots velocity, a velocity type model, or a penetration type model, where you understand how big the pie is, and you understand how big your piece of pie is. Then you can add variables into that to then explain what it's going to look like in the future if you know what the pie is going or your piece of the pie is going, or if your velocity, how much your velocity is going, then you can start doing things. Those are relationships. So it's causal relationship type of modeling. It's great when there's multiple drivers. If you have just your level, trend, seasonality, and time series, that noise, something is causing that noise. Can you explain the noise? Is it an external variable? Is there multiple external variables? That's what we're finding right now. Through COVID, 2/3 of organizations have gone to some external variable to try to explain what is going on because their order history is crap. It doesn't work as well. So they need to start looking externally to try to explain things. 2/3 have went to some external variable to try to explain what's coming on. Hopefully you're within those 2/3. If not, get on board because that's what we need to start doing. Consumer behavior is changing. Times are changing. Time series is only going to get us so far. That's when we really need to start looking at those external variables to start explaining things. That's where causal and relationship type of models. And you can use it with time series. That's what a lot of organizations are doing now, is finding those external explanatory variables and bringing that into their time series to help explain the noise or to explain a portion of the time series and kind of putting those models together. When it comes to causal models or relationship models, they're simple ratios, which I explained just a part of a whole. They're looking at simple regression, linear regression, multiple regression. There's logistic regression, starts getting more into probabilistic, yes-no type questions. So those are some of the most common causal or relationship methods. I do want to mention machine learning because that's the other far right of the equation. When you're looking at machine learning, these algorithms differ just a little bit in that they take information from a previous iteration or training data set and then apply it to help build out the current or future models. So you actually either in supervised, you're going to provide the answer for it in a training set, or it's going to use iterations and help define what the training set should be. But either way, it can handle multi-dimensions, multi-variety of datas. It's dynamic environments, so it can do a lot more. That said, there is a learning curve for some people, and there's an interpretability. Not to scare you off, there are basic things you can start doing today to start being able to model, or at least get the foundational pieces so you can start modeling. Some of the most common things from a foundational aspect that are being used is Bayesian. Understand, simple naive Bayes, because it will help you understand and other types of models you can do with it. It's simply a probabilistic type of algorithms based on the Bayes theorem. Looking at logistic regression, that came actually from some of the causal, utilizing some of those regression with yes, no, or other types of questions that you can actually start bringing in and doing other types of modeling with it. Logistic or linear regression can feed into a neural network. You have decision trees, neural networks. Those are two different structures that you can actually bring in some other types of modeling into and build it out into like classification problems or predictive problems there as well. Ultimately, you can come up with the answer of if you're 55 years old in first class mail on the Titanic, what's your probability that you're going to survive? Once you start understanding some of those, then you can utilize those in forecasting then as well. The last class of methods I want to talk about are clustering, because they're being utilized a lot more today in demand planning, business forecasting, what you're doing right now. We're starting to bring in, because the question comes in is not all items are created equal, or we have all these different patterns. How do I start looking at these a little bit differently? That's where clustering, segmentation starts to play in. It helps you understand and analyze by putting a large group into smaller, manageable subgroups based on different types of criteria that you may want. Those groups can then be used in other modeling, for other analysis. I said segmentation. You can decide where you want to focus your time, which attributes you want to put, which models you want to do with which items. All those things help if you can find manageable subgroups. That's where clustering methods play in. Some of the most common clustering is a constraint-based. Constraint-based is a rules-based method. Think of Pareto. That's a rules-based method. 80-20 rule. 20% of my items are 80% of my volume. That's a rules-based type of if-then logic that you applied to it to be able to create your groups. Most ABCs type of classifications are based on some type of constraint type rules-based methodology. But then you can get into other ways of looking at breaking it down, anywhere from hierarchical, where it uses a dendrogram and it goes down to a certain level that manageable groups. Distribution looks at the distribution of the points, and then centroid, one of the most commonly used, k-means, where you're looking at the distance from a center point of the clusters that you define or allow it to define. So those become some type of k-means, which is a centroid based. All those are different ways of taking a large data set, breaking it up into smaller manageable data sets, either groups that you define, a number of groups you define, or allowing it to define the groups based on hierarchy, wherever you want to look. That's a way of defining some different clusters. So with that in mind, how do you pick which is the best one? I think the best way to get started is to understand your project. Understand why you're forecasting. Think of the time. How much time do you have? Decide on your error tolerance. And then from there, balance that interpretability with accuracy and time. Start simple. Naive may get you there. Build upon that to where you meet your predefined what you're looking at. And remember, there's no magic bullet. Really understand each method we talked about really has a different purpose for it. It's not just a hammer, it's a screwdriver, it's a wrench. There's a lot of different, ways you can slice and dice and use the data you have. That's the reason why we have this toolbox. Start to familiarize yourself with all the different tools that are in your toolbox, maybe in your system, that you can use going forward. Hopefully this high-level overview helped you. If not, you got any questions, feel free. Let me know. You can find me. And as for my favorite alpha, I'm thinking maybe if I had to choose, of course, the answer is it depends. But if I had to choose, my answer is going to be 0.42. My name is Eric Wilson. You can find me at eric@ibf.org, eric@ibf.org. Let me know what your favorite alpha is, or beta, or model is. If you got a model that you want to talk about, hey, let me know in the comments or email me, eric@ibf.org. Happy to maybe talk about it in a future episode. Bring you on. I want to thank Arkiva, your one-plan S&OP software solution. Hopefully you can check them out at an upcoming conference, and check me out at an upcoming conference as well. We got a lot going on. We're back in person. I'm excited. In June, we're going to be back in Chicago. I had a great time a couple weeks ago in Chicago. I'm going to have wonderful time with you in Chicago as well. It's the 15th through 17th in Chicago. It's going to be an S&OP Best Practices Conference. There's going to be a lot of different thought leaders there sharing what they're doing in their organizations. Always a good conference to come to. Check it out at ibf.org. So please check that out. Check out the other conferences coming up after that as well. And remember, no matter which method you use, you don't want to forget, wash your hands.